Good day everyone, I welcome you to the show of Massive Quality Mathematics. So today I want to take you through lecture 2 of integral calculus, specifically focusing on indefinite integral. So indefinite integral, the process of finding antiderivative is called integration. So that process we were doing of finding antiderivative is called integration. So let's talk about the definition of integration. So the definition says the collection of all antiderivatives of a function f is called indefinite integral with respect to the variable x and is denoted by integral of f of x dx equals to antiderivative of f of x plus a constant c. So the symbol like s is called an integral sign. A symbol shaped like s is called an integral sign. The function f under integration is called integrand. And x itself is the variable of integration. So it's the variable that we're integrating with respect to. So this is in short the definition of what is integration. Remember that the process that we were doing in the first lecture is called the process that we're doing of finding antiderivative is given a name called an integration. So let's look at the basic rules of integrations. There are some rules that we must take into consideration of integration, but we'll take you back in integration formula. We'll compare this with integration formula versus differentiation formula. We'll be looking at integration formula versus differentiation formula. So it is a common knowledge that the derivative of a constant is 0, provided that c is a constant. But in an integration, the integral of 0 with respect to x is a constant, since you can see. So we have the power rule in the integration and the power rule in the differentiation. So the derivative of a function x to the power n, we say is nx n minus 1. So we say is n times x, in the exponent we subtract 1. So but the integral of x to the power n dx, as we talked about it yesterday, is we add 1 to the exponent and divide by that exponent, which is x to the power n plus 1 over n plus 1 plus a constant c, provided that n is not equivalent to -1. Because if it's -1, then the denominator will be 0, which is a taboo to divide by 0 in mathematics. So the derivative of a trigonometric function sine is cos of x, but its integral, as I was talking yesterday, that we ask ourselves in the previous lecture, that we ask ourselves that what is that we differentiate to get this sine x. Obvious is when we differentiate cos, we get negative sine x. So we need negative of cos, so plus a constant. So similarly, the derivative of a trigonometric function cos x is negative sine x, but the integral of cos x dx is equals to sine x plus c. The derivative of a tan x is equals to sec squared x, but the integral of sec squared x, we ask ourselves what is that we differentiate to get sec squared x. Obviously is tan x. Then the integral of sec squared x dx is nothing but tan x plus c. So moving to the other rules. So the d over dx of cot x is negative cos sec squared x. But when we integrate these cos sec squared x, we ask ourselves what is that we differentiate to get this cos sec squared x, which is negative cot, because when we differentiate cot x, we get negative cos sec squared x. So we need negative of cot x. So we have negative of cot x plus c. Number 7, the derivative of sec x with respect to x is nothing but sec x times tan x. But the integral of sec x times tan x dx is nothing but sec x plus c. So similarly, the derivative of cosec x with respect to x, it's negative cosec x times cot x. But the integral of cosec x times cot x is negative cosec x plus c, because if we differentiate these cosec, we get negative cosec x times cot x. So we need negative of it to have cosec x times cot x. So number 9, we have the derivative of natural exponential function e to the power x with respect to x, which is straightforward. This is a very stubborn function, so it doesn't change when we differentiate it. It remains as e to the power x, but when we integrate it remains at itself, but we add a constant, because that's a normal way we do the process of integration. So we talk about the theorem which says that antiderivatives are not unique, so we are free to add some variable. So we have the integral of e to the power x dx equivalent to e to the power x plus c. So number 10, we have the d over dx of ln of x, which is just equals to 1 over x. So but the integral of 1 over x is just ln of absolute value of x plus a constant c. So I hope this is very clear. So number 11, d over dx of the exponential function b to the power x is equals to b to the power x times ln of b. So this meaning that the integral of b to the power x times dx is just equal to the b of x over ln of b plus a constant c. So that's how we easily do it. So the derivative of the inverse sine x with respect to x, it's 1 over square root of 1 minus x squared. But when we these are called inverse trigonometric functions, so we are also going to discuss much about them, so at a later stage. So the derivative of sine inverse of x with respect to x is 1 over square root of 1 minus x squared, but the integral of 1 over square root of 1 minus x squared with respect to x, we ask ourselves again, what is that we differentiate to get a 1 over square root of 1 minus x squared, which is nothing but the inverse of sine x plus a constant c. That's how we do it. Similarly to tan, so when we differentiate the inverse, tan inverse of x, we get 1 over 1 plus x squared. But when we integrate this 1 over 1 plus x squared with respect to x, we get nothing but inverse of tan x plus a constant c. So 14, we have the d over dx of inverse sec of x, which is equals to 1 over absolute value of x times square root of x squared minus 1. Its integral, it's nothing but sec inverse sec of x plus a constant c. So these are the things. Now we have what to call the other basic rules of integration. So we have other rules of integration. We have other rules of integration. One is a simple thing. So the integral of a constant k or c whatsoever, f of x dx, then we are allowed to take this constant outside of the integral sign, which will be f of x dx, and we just integrate f of x. So number 2 is the sum rule. So the integral of two different functions, f of x plus or minus g of x. So we are allowed to integrate separately each function. So this would be f of x dx. Don't forget we have the x here, dx plus or minus g of x dx. So those are other rules of integration. So we have what we call the trigonometric identities. So it's also important to recall trigonometric identities. There are some of the trigonometric identities that you have to understand. So we have a trigonometric identity which says sine squared of x plus cos squared of x is equals to 1. So then from this one we can have what to call, if we divide by cosec squared of x, we can have sine squared x over cos squared of x plus 1 equals to 1 over cos squared of x, which will produce a second rule which says tan squared of x is equals to this is what called sec squared of x minus 1. So it can produce this law. Again, if we divide by nothing but sine squared of x, you can have another law which says cot squared of x is equals to, because we are dividing by this one, we have cosec squared of x minus 1. It will be cot squared of x equals to cosec squared of x minus 1. So if we can go back to the same first rule again, or the first identity, sine squared x plus cos squared x equals to 1, we know that we can do something like this. We can have sine squared of x equals to 1 minus cos squared of x. We can have this thing, but we have double angles. Let's say it's 4, which is the fact that cos of 2x equals to cos squared x minus sine squared x. These are double angles. But if where there is sine squared of x, we can substitute 1 and 1 minus cos squared of x. We can have cos squared of x minus 1 minus cos squared of x. When we distribute, we have minus 1 plus cos squared of x. It will be 2 cos squared of x, then minus 1. So we can take this one this side, then we have something like 1 plus cos 2x equals to 2 cos squared of x. So when you divide by 2, we then have the identity number 5, which is cos squared of x equals to 1 over 2 into 1 plus cos 2x. This is the other law. Similarly, if you can say we have because we have this one, if you can say we have cos squared of x equals to 1 minus sine squared of x this time around, so we'll have from number 4, which is a cos 2x, we'll have a cos 2x equals to where there is cos, we'll be putting 1 minus sine squared of x minus sine squared of x. So this one will add up to minus 2 sine squared x. So when you take 1 that side, we can have 2 sine squared of x equals to 1 minus cos 2x. So this will be, therefore, sine squared x equals to 1 over 2 into 1 minus cos 2x. This is the law number 6. So we know that we also have got a double angle. Sine 2x is equals to 2 sine x times cos x. You must be aware of these, guys. Again, we have something like another laws like expansion laws, to say sine of x plus or minus y, it's equals to sine of x times cos y plus or minus sine y times cos x. So that's what we talk about. Number 9, we have cos of x plus or minus y, it's equals to cos of x times sine y minus plus, because if it's plus it should be minus this side, if it's minus it should be plus this side. So it will be cos y times sine x. So these are what you call the trigonometric identities, double angle, that we have to understand, that we have to somehow understand when we talk about them. So yeah, so now we can move to examples, so to apply those formulas and those rules. So let's go to examples. Let me erase this part. So now we can go to examples. Says find the indefinite integrals of the following problems. So we have the integral of x plus 1 times x squared minus 2 dx. So how do we go about this one? So this will be equals to, we have to simplify this first, because there is no other law to do this kind of problem. So then we need to simplify these two binomial. When you multiply, we got x, this one and this one is x cubed minus 2x, then plus x squared, then minus 2 dx. So when you simplify, we got x cubed minus 2x plus x squared minus 2. Then this will be equals to, when we add the like terms, we have integral into x cubed, then we have plus x squared minus 2x minus 2 dx. We don't have like terms, so we just have now to use the sum rule, that we have to integrate each function separately. We need to integrate x cubed dx plus we integrate x squared dx, then minus we integrate 2x dx, then minus we integrate 2 dx. We know that this is equals to the integral of these. Here we are allowed to take out the common factor, which will be x dx, and even here minus 2 dx. So then we have to integrate now. When we integrate, we use that power rule. So this will be 1 over 4x to the power 4 plus we add 1 to the exponent is 1 over 3x cubed. So then minus we add 1 again, it will be 2 over 2 times x to the power 2 minus, then this one the d and the integral cancel each other, then we have 2x. So when we simplify this, then we have 1 over 4x to the power 4 plus 1 over 3x to the power 3 minus x squared minus 2x plus a constant. So that's how we integrate. So we add a constant. So this is the answer. This is the final answer. So let's go to the second problem. So this is quite similar to that one. So we just have to simplify. You know that there's not any law which tells us to integrate something like this. So we have to simplify. So then you know that we can divide by x squared to each term, which will be this minus 1 over x squared, then dx. This is just equals to integral, then this and this cancels, then we have 2 minus, we can write this as x to the power minus 2 dx. So this will be equals to, then we integrate each function like this, the integral of 2 dx minus the integral of x minus 2 dx. So here we can take out this common factor, which is 2, no, constant, which is 2, not common factor but constant, outside of the integral sign, minus x to the power minus 2 dx. So when we integrate, then this will cancel with this one, then we have 2x, then minus 2 plus 1, it's minus 1, 2b plus x to the power of minus 1 plus c, which can be written as 2x plus 1 over x plus c. So this is the final answer for that problem. So we can move to the next one, which is cot squared x. So now there's not any law which tells us, or any rule which tells us to differentiate, to integrate these kind of things called squared of x. So we need to use, we know that from sine, so let's say rough, we know that from sine squared x plus cos, from this trig identity equals to 1, if we divide by cosine, if we divide by what we call a sine squared x through each and every term, sine squared of x, so then we'll have what to call, here we'll have 1, but here we have what to call a 1 over tan, which is cot squared x equals to 1 over sec squared x is a cosec squared x. So this will imply that cot squared x equals to cosec squared x minus 1. So this is what we're going to use there. So here that means in the place of cot squared x we put cosec squared x minus 1 dx, because we've proven that this is equal. So continuing from there, we have this is equals to, then we will integrate separately. This will be cosec squared x dx, then minus dx. So this is just equals to, what is that we differentiate to get cosec squared x? Obvious, this is negative cot of x, then here it's minus x because this one goes away, then plus a constant, and this is the nice answer for that particular problem. So we have number D. We have this cos 2 theta, but we told you that cos of 2 theta, the double angle, it's equals to cos squared of theta minus sine squared of theta. So this will be equals to integral. In the place of this one, we put cos squared of theta minus sine squared of theta, but all divided by cos theta minus sine theta d theta. So in place of cos 2 theta, we put this expansion. So this will be, but we can factorize this because this is the difference between 2 squared. It's like if you let x to be cos theta and y to be sine theta, will be having cos squared of theta minus sine squared of theta is equals to x squared minus y squared, where you can factorize like this: x minus y, x plus y, because it's the difference between 2 squared. So that's what we're going to apply here. So this will be cos of theta minus sine theta into cos of theta plus sine theta, all divided by cos theta minus sine theta. So remember, we have the variable we're integrating with respect to, which is d theta. So this guy and this guy can go away. So we can have integral of now cos theta plus sine theta d theta. So here we can integrate separately. So we have cos of theta d theta plus integral of sine of theta d theta. So the integral of cos of theta d theta, we ask ourselves, what is that to differentiate to get cos theta? It's obviously sine theta. To get that one, it's obviously negative cos theta plus a constant, and this is the answer for this problem. So I want to take you back. There's something that I want to rectify. So in the trig identities number 9, I said that we have cos of x plus or minus y. So let me write this clearly. So I said that we have cos of x plus or minus y equals to I said it's cos of x times sine y minus plus sine of x times cos of y, which is not correct. So the correct thing that we should have there is 9 is cos of x plus or minus y is equals to what you call cos of x times cos of y. If you've got plus here, we've got minus here. If you've got minus here, we've got plus here. Should be cos y times cos x. So that's how we do it. No, not that. It should be sine. It should be sine x times sine y. So that's how we do it. So I wanted to rectify this kind of mistake. So this is the correct notation. So this is how we do it. So let's move to the other problem. So let's move to the other problem. So other example, which is number E. So you can pause and try out this one. So this is the integral square root of t plus t square root of t over t squared dt. So here, what we need to do, we don't have any rule associated with this kind of problem. So what we have to do is to undergo simplification in order to do this problem perfectly. So then this is quite simple because we are associated with something like square root of t. We need to convert this into this set form into an exponential form. So this will be just equals to integral. So this guy becomes t to the power 1 over 2, then plus t times this guy also becomes t 1 over 2, all divided by t square, then dt, then so dt. So this will be just equals to integral. So we'll be having t 1 over 2 plus t times t to the power 1 over 2. We use an exponential law. Because of the same base, then we add the exponent. This will be t 1 plus 1 over 2. It will be 3 over 2, all divided by t to the power 2 dt. So this will just be equals to integral. So then we'll divide each term in the denominator by t to the power 2, which is t to the power 1 over 2 divided by t to the power 2 plus t 3 over 2 divided by t to the power 2, then dt. This is just equals to, then we'll be having integral. So when we do this kind of problem, we know that we'll be having t 1 over t minus 2. So we'll be having t 1 over 2 minus 2 over 1, which is just it will be 1 minus 4 over 2, which is just minus 3 over 2. So this will be t minus 3 over 2, then plus it will be t, this is kind of like rough work, t 3 over 2 minus 2, this is just equals to 3 minus 4 over 2, which is just minus 1 over 2. This is t minus 1 over 2 dt. So this is dt. So let's erase this rough work so that these problems cannot be mixed together. So this will be just equals to, we need to integrate each because these two functions cannot be combined together into a single expression, then we need to integrate each function separately. So integrate this, it would be t minus 3 over 2 plus 1 minus 3 over 2 plus 1 which would be just 1 minus 3 over 2, which is a 2 minus 3 over 2, which is just minus 1 over 2. It means that we'll be having minus 2, we'll be having equals to minus 2t minus 1 over 2, minus 1 over 2, then plus, here we'll add 1 again, it's minus 1 over 2 plus 1, which will be 1 minus 1 over 2, which is 1 over 2. It will be 2t 1 over 2. It will be that 1 over 2. So this will be equals to, you can say it's equals to minus 2 divided by root of t plus 2 square root of t plus a constant. So yes, plus a constant. Immediately after integrating, we need to add a constant. So this is the final answer for that problem. So it is just for write it here clearly, it is just minus 2 over root t, then plus 2 square root of t plus c. So this is his final answer. So then we can go to this last problem. So you can pause and try it before I do it. So this is an integral of x divided by root of x squared minus x to the power 4. So we need to simplify. This is a very simple problem because what we have to do is to simplify. We know that here under the square root, inside the square root we can take out x squared. We can take out let me say x squared. So this will be x squared into 1 minus, when you take out x squared here, we remain with x squared. This will be just equals to integral. So we know that in mathematics you've got the square root of a times b. We are allowed to have to write it like this: square root of a times square root of b. So this one will be x over this will be square root of x squared times square root of 1 minus x squared dx. Must not forget dx. So this is equals to the square root of x squared is x. X will cancel with x, so we have the integral of 1 over root of 1 minus x squared dx. So we have 1 over square root of 1 minus x squared. So which law are we talking about here? So this one, what do we differentiate to get this guy? We differentiate inverse sine inverse of x plus a constant. So if you still remember from that table, so this is how we approach this kind of questions. The trick here is to know where you are going. So you have to know that to approach this kind of question, I have to use some inverse of trigonometric functions. So because yeah, you can see that is something related to something that we discussed in the table. So yeah, otherwise that's how we simply do it. So yeah, this come to the end of our session, end of our class. This come to the end of our class. So please support me by subscribing, liking, and sharing my videos. So if you've got any problem concerning the basic introduction of integration, then you can let me know. You can post it, you can comment, you can post it in the comment section, or you can send it to me via email so that I can assist you wherever you are coming across the challenge. So otherwise, thank you very much for your time to go through my video, to listen to whatsoever that I'm saying. So thank you very much.